Welcome everyone. Like Reese said, my name's Jameson Watts, and I am the founding dean of the School of Computing and Information Sciences. We've been doing this for, going on 6 years now, and we keep growing every year. It is a crazy process, but it's clear that something has resonated in the marketplace here. Folks are realizing that data is everywhere, often messy, and we need more folks who know how to deal with it and know how to help organizations deal with what they have and creating the future. So I'm going to give you just a little bit of an overview of what our program is all about and what you could expect if you end up joining us. All right. Masters in data science. You should all know that because you're here. You signed up, but I guess this slide is still here. I'll see if I need a revision next time. But maybe for those of us on the recording who get to see this later on. All right, what is a data scientist? Variety of definitions out there. You could probably ask one of the robots and they'll give you something else. But I somewhat like this definition, right? You have to know a little bit of programming in order to build the software. But you also need to have some skills with data management, data munging, data cleaning. And then you need some of that modeling ability as well, right? So some of the stuff that comes from statistics and computer science algorithms so that you can derive insights from the data that you're working with. Um, okay, fair, reasonable. This is how most people explain data science, right? It's a little bit of programming and a little bit of statistics. What I would argue is that there's something in missing from the automation side of things and the modeling side of things, and that is context. And you can't really be a proficient, productive data scientist unless you go deep in some context. And it doesn't have to be just, social media algorithms. It's all over the place. I have students and friends of mine who are data scientists at the state, and they are building models to place kids in foster care. I have a friend who works for uh, the city of Portland, tracking salmon migrations in the Columbia River, using sensors that are attached to the heads of seals, which is kind of a cool project. There are environmental data scientists. We just hired a brand new marine data scientist who joined the faculty this year. We've got a computer vision data scientist who's on the faculty. So if you want to learn how to use visual data to make sense of the world. And so you have to have something kind of vertical, something contextual that really is the source of the insights. And if you don't have a deep knowledge of that context, you're not going to be a very productive data scientist. If you think about the kinds of things that you might do that exist at these intersections, right? On the programming side, well, programming is all about automation. Well, if you need to automate something related to a context, it's usually managing that data, moving it around, combining it, recombining it, cleaning it, sending it to different spots, putting it in different formats. And then, of course, on the modeling side, you get some results from your statistics, but you don't know how to interpret those results unless you have some deep understanding of the context as well. And so, context is clearly a huge part of what it means to be a data scientist these days. And of course, you can't present your findings unless you actually know what you're talking about. So, one way to think about this is that data scientists aren't just one thing. They're many things. And part of a student's journey through a program like ours is trying to figure out what flavor of data scientist resonates most with them. And we have students who have found jobs in all of these different areas. If you're really interested in the programming side of things, you might look at something like machine learning operations, which is the practice of taking models and putting them into production in a scalable way, right? You need some pretty deep programming expertise to do that. Maybe you want to be a data engineer. So you know a lot about the context. You're really interested in trying to figure out how to take that spaghetti mess of data that every organization deals with and clean it up into something that's usable. As I'll talk about in a little bit, there are a lot of jobs in that area of data science. We just had a recent event at our downtown campus in Portland, and one of the speakers there is a former student of mine who is a management consultant. And she uses her knowledge from the data science classes that she took to kind of bridge the gap between the business-minded folks at an organization and the engineers that are actually implementing some of that work, and does so quite well. And then as you kind of circle around counterclockwise, maybe you're a data science manager, right? You know a lot about the context, and so you're providing an internal interface between the decision makers and the doers at a company. And then, of course, pick any word you want, put analyst after it. And there are folks trained in data science doing that job, whether it's financial analysts, business intelligence, et cetera, et cetera. And then, of course, if you are just the hardcore math-obsessed statistician type, then perhaps you take on the title data science, data scientist, and you are in there working with novel models and the math behind the models in order to do something very specific for a given organization. Why might you data science? Well, it's often rated as one of the top jobs that you can have. A lot of flexibility, a lot of kind of rewarding career opportunities. It's creative, it's fun. You can make a bit of money. This one is pretty new, but also pretty important. You're going to learn a lot about how machine learning and AI works in a program like ours. And getting that kind of knowledge on your resume is really valuable these days when you are going out and competing for tech jobs where everyone is trying to implement generative AI in their organization. You can't actually successfully implement Gen AI in an organization specific way unless you have folks who understand the data, can organize it and prepare it for those types of models. Moreover, you might need to learn something about how LLMs actually work in order to know whether the particular implementation of that generative AI for your organization is going to do what you want it to do. And so our program offers exposure to that kind of content as well. And of course, data is everywhere more than ever. Most organizations don't know what to do with it, how to deal with it, or how to make it valuable. And so there are lots and lots of opportunities for enterprising and entrepreneurial individuals to go in and help organizations make sense of that spaghetti. All right. How do you actually do it? Well, we looked, and all of the roles that I talked about in the previous slides come with a set of skills that are requested. These are the skills that are most often requested by industry. So you need to have some coding ability, not kind of deep software engineering knowledge, but basic scripting, familiarity with software development environments, and familiarity with how to actually write script to do data science style work. typically in either R or Python, sometimes both, depending on whether you are internally focused on analytics and statistics, that's more R-oriented, or whether you are externally oriented and production focused, that tends to be a bit more Python focused. Data engineering, for sure. You got to learn how databases work, relational databases, non-relational databases, data warehouses, data lakes. Data lake houses, I guess, is a new term that someone's used to describe the combination of these things, which is a popular model of warehousing data these days. Regardless, the one thing that hasn't changed in the last 30 years is the importance of SQL as a language for describing and organizing data. And you definitely get exposure to that in our program. And of course, machine learning. And of course, machine learning extends into deep learning and generative AI as well these days. What they don't talk about, but what I know to be a fact, is that communication is the skill that sets you apart from the other propeller heads on the team. And if you can't actually take the insights that you've spent weeks and weeks developing and successfully communicate those insights to someone who doesn't have very much technical knowledge, you are not going to have an impact, and you are not going to be recognized for the work that you've done on the technical side of things. So we focus on this. We give you opportunities to do projects and to present your work and get feedback on that presentation of your work so that you are ready to communicate these pretty complicated topics to folks who have varying levels of understanding of what's going on under the hood. So this is a graphic from Shopify, which tries to explain the hierarchy. They call it the hierarchy of needs. I think it's really the hierarchy of organizational needs, meaning how many jobs are there that exist out in the world related to each of these types of things. Like I was saying before, anything related to data engineering, so collecting all of the data, moving it around, preparing it, etc. Tons of work out there for that. You move up this pyramid and you get into more of the insights. So exploration and transformation, so exploratory data analysis, fewer of those roles. And then at the very top, of course, is actually generating the models and doing the deep learning work. This is surprising to most folks who are casual observers of the data science profession. They think that we kind of sit in front of our computers and write models all day, when in fact, most of our time is spent on the data engineering side of things, the data quality side of things, the data governance side of things, and much less of our time is on the actual modeling. In terms of difficulty of understanding and communicating, I think the very top of the pyramid is the hardest, and the further you go down, the easier it gets. And so the amount of time you spend studying, for instance, AI, deep learning, machine learning, is a lot because it's really complicated, even though the amount of time you actually spend doing that sort of work within a role as a data scientist is much less than some of the less complicated things. So let's get to our curriculum. So we designed something that was based on what we're hearing from industry, and essentially everything that you need and nothing that you don't. So you get in 3 semesters. If you take this program full time, you can complete your degree with 3 classes per semester for 3 straight semesters. Next fall, the curriculum will be Foundations of Data Science with R. This is about learning to code in R and also doing kind of foundational work in statistics. There's a course on data ethics, policy, and human beings, which gets into the ethics of using data, how data governance works in organizations, and a survey of the current kind of ethical and philosophical problems that are abundant in the industry at the moment. And then, of course, Python programming for data science, which is much more on the programming side of the discipline and getting you ready to use a lot of the data science-oriented packages within the Python programming language that will enable you to do some of this more advanced stuff. In the spring, we moved to data engineering. So this is all about SQL, relational and non-relational databases. You get a course on data visualization and presentation. So this is not just learning how to create charts and graphs, but it's learning the theory behind effective data visualization and effective data communication as well. And then you get your first course on machine learning. Over the summer, we follow up with advanced courses in data engineering and advanced courses in machine learning and your capstone project. And that capstone project is where you get to take everything that you've learned over the year and work with typically a team on a project of your choosing on a soup to nuts data science project. Which incorporates elements from each of the classes that have come before. We also give you opportunities to engage with our career professionals at the university. We have a large career center, and we have a dedicated career advisor for our graduate programs. She makes herself available before class typically, and also for one-on-one consultations. But beyond that personalized care, we also have scheduled events. So in the fall, we have a major networking event. We just had this event last week. I think we had, Reese, probably over 100 folks there, didn't we?
Yeah.
Yeah. Yeah, it was a great event. We had an academic talk, we had an industry talk, and we had lots of food and drink and interesting conversations. Our career advisor hosts various pizza workshops to get you ready to update your resume, depending on whether you are looking for something new, looking to change your career, looking to advance in your own career. She is skilled at helping folks with all of those scenarios. Moving into the spring, you can expect more individual advising, starting to try to put your projects into portfolio format, looking at the career that you want and how your skills match up with what you want. And then doing an evaluation of the career landscape at that point in time. The summer is when the rubber really meets the road. We have industry professionals coming into your capstone class and talking. We have scheduled events. We have several mock interview sessions where we have friends of the program, alumni, and industry professionals coming in and giving you a chance to actually practice doing a technical interview with them, and you will get feedback from those interviews. And it's also a great way to make contacts with a lot of folks who are already doing this in the industry. And I don't think I missed anything. I think we got there. And then eventually we send you off at graduation and you go do amazing things in the world like all of our other students. So, recent placements, bunch of cool ones. One of my favorites is we sent someone to the San Diego Padres. It was his dream job. He's now doing like sports analytics for them. But we send folks everywhere. local companies like the Standard Insurance and Daimler, State of Oregon, get a lot of our graduates, but we also reluctantly send folks north and south to Seattle and San Francisco on occasion, and so I have students working at Nordstrom or PitchBook and other folks like Boeing and that sort of thing as well. One of my very early students is actually a machine learning engineer for Call of Duty Mobile at Activision, which is a really cool job. And he comes in and hangs out with our students on occasion to talk to them about it. Some details, and Reese can probably answer additional questions here as needed. But 36 credits over 3 semesters or 12 months. It can be taken over 24 or 36 months. We typically have roughly 30 or 40% of the students in a given year who are part-time rather than full-time, either because they have other life responsibilities or they are working a full-time job while attending this program. Classes are evenings, once a week. So if you're taking 3 classes, a full-time schedule, it will be 3 times a week, one night per class for 3.5 hours each class with a half-hour dinner break in between. Let's see. If you happen to be a Willamette alumni, then you get an automatic tuition discount. But all applicants are automatically considered for merit scholarships. We do our best to try to help you, provide a package that makes sense for you. Application, resume transcript, essay, and 2 letters of recommendation. Fairly simple process. Mostly we are looking for your kind of readiness and ability to enter into a technical program like this. There's no GRE or GMAT required, but we do like to see at least a little bit of programming or statistics experience. If you don't have those things but are otherwise really interested in learning them, we can provide resources to take free Coursera classes ahead of the program so that you're ready to enter and hit the ground running. And I think that's it. What questions can I answer for you?
I mean, that was pretty all-encompassing, honestly.
Nothing burning? Let me know.
I guess I got one question for you. I'm curious to know what your kind of typical student, where they're coming from, what's their background. Yeah, what are they all fresh out of undergrad? Is there like an average kind of distance between undergrad and matriculate into the master's program?
I don't know that we have a typical profile. What I will say is that we tend to have 2 fairly distinct groups, some of whom are coming directly from undergrad. And they tend to have more current tech skills because they just finished their undergrad. They're probably remember their statistics class, for instance. And then we have groups of individuals who've been in the workforce for some amount of time, and they're coming back and either looking for a career change or a career upgrade. And both of these groups bring different strengths to the classroom. And it's often really useful to have context from the folks who've been working for a while. And it's often, nice to have, some of the new skills and toys that, the straight out of college folks bring to the table. because they, were just in a classroom, right? Literally the year prior. And so often when you host discussions, you can have really interesting dynamics between these groups. And it can be useful to pair up on projects and other things like that, so that each person is bringing some strength to what you're trying to accomplish. In general, the students who are most attracted to a program like this type come from backgrounds that are not necessarily full tech, although we've had, you know, uh, math and statistics and computer science majors who enter and do quite well. Um, but often we see folks who are, tech or science adjacent, right? So they might, if they're coming out of undergrad, they might have a degree in environmental science or physics or chemistry. And they took a programming class or two, and maybe a statistics class. But they want to take that contextual knowledge and gain the data science skills so that they have that kind of grouping to take out into the world. And on the industry side, we see similar things, right? Often we'll have someone who's working in healthcare, and they realize, oh my gosh, my hospital has got all this data that they have no idea what to do with. And it's clear I need some new skills in order to help them help themselves, right, in some way. And so, that's typically what's motivating folks to come in and join a program like this.
Great. Thank you.
I have a little bit to add too, Jameson.
Sure.
So a few interesting things, right? So we have our two cohorts, Portland and Salem. In Portland for this year, the cohort that started in August, it was actually a lot more people who had spent at least 2 or so years in industry doing some work and then coming back to get their education, as opposed to all students coming straight out of undergrad. And the interesting thing about the Portland group was that their background was were super varying, right? But the most common undergraduate program that they were coming out of, even though they're a little removed from that, but their academic background was biology was our biggest one coming in this year. And it was a lot of these folks who had either gone into some research style roles in industry or some, I don't know, roles more kind of related to the applied sciences and biology, and realizing the need for more data proficiency within the practices they were seeing in their work, right? And then wanting to upskill in that way, because they could kind of see the way science is heading and the needs in the science industries, right? And stuff like that. In terms of people who have come in with more kind of computer science-y backgrounds, it's often people who maybe have a lot of software engineering background, but maybe want to get their hands dirty with a lot more machine learning and more data style kind of programming, right? So for example, I'm thinking of one student in particular who joined this year who was computer science through and through, and got really excited about machine learning and data. And he was like, I want to kind of expand what I'm doing, right? So it's kind of, from what I see, it's all across the board, right? But those are two pretty common pathways. So yeah.
Awesome. Thank you.
All right. I had a question, I guess. I'm coming from this vein. I'm coming from the industry, right? My degree was in computer science 25 years ago, so I'm kind of a graybeard. And I've been in the private sector for the last 25 years, mostly doing connectivity, but I'm kind of interested in AI and the deep learning stuff. And so I was looking at updating, what I do. But I was wondering about the statistics. That was 25 years ago. I can relearn it, but yeah.
Well, so it's mostly conceptual, right? So yeah, there's some math, right? Maybe you have to learn the equation for a standard deviation or something like that, right? But it's mostly trying to understand the concepts behind statistics.
Okay.
So if you think about data, right? Data is an approximation of some underlying thing, right? So, we have like a demographic, characteristic like height, right? And, we might use that as a proxy for, I don't know, how good you are at volleyball, right? Or something like that. But it's really not how good you are at volleyball. It is trying to kind of get at this latent concept of skill, right? And so you have to understand how error matters, because you've got this piece of data and then you've got skill in volleyball. And there is some correlation, but there's a lot of messiness, right? There's a lot of variation around that trend. And so conceptualizing what that variation means and why you have to think about that kind of error, right, is the sort of thinking that we're trying to promote, as opposed to just how do you calculate standard deviation and a confidence interval on a trend line or something like that. And the reason is because, right, most machine learning algorithms are all about minimizing error. And so you have to have some foundational understanding of what error is to begin with and why you might really want to consider minimizing it, right? And then you can expand that knowledge into the machine learning realm and try to understand how these models are dealing with it.
Okay, yeah, I can do that. I wasn't sure if I had to go back and relearn all my calculus and stats and linear algebra again, after this many years, like, oh, I guess, but
Probably not calculus.
okay.
Yeah. Well, any other questions?
You
Anything
said
else
completion in 2 to
yeah.
3 years. Obviously I'm working,
Yeah.
well, now obviously, but I'm working full time, and everything else. Does it 2 years like hard? Because I might try to stretch it. I'm not sure if I want to
So,
do it full time, right?
I mean, so we have had, everything. So, I have had students who are full-time workers who also do this program full-time. It's a lot. And, you know, they didn't really see their boyfriend for 12 months, right? But they got through it, and they were happy, that they did. But it's a lot. The way to think about it, I think, concretely would be, you're going to spend 4 hours in the classroom per class each week. And you're probably going to spend 4 hours outside of the classroom for that class each week. And so, if you've got 3 classes, that's 8 hours in class, or that's 12 hours in class and 12 hours outside of class, right? And so probably a minimum of 24 hours, per week is a reasonable estimation. For some, it's more than that, right? Some folks take more time out of class, right? They will spend 6 hours or 8 hours per class doing homework and assignments and project work. And so I think that on the low end, right, it's 20 hours a week to be full time. And on the upper end, it's 40 hours a week to be full time. And you really don't know until you get in and just see how it goes. And so often what we suggest is that for folks who are working full time, register for 2 or 3 classes and just see how it feels for the first week or two, and then drop one or two of those classes, as needed, basically, depending on how you kind of calibrate against the workload.
Okay, so things haven't changed in 25 years. 'Cause that's how I used to work it.
Yep. All right, Reese, anything else these folks should know?
I'm trying to think. We have a couple minutes, so just a few things that I usually see people are interested when I'm boots on the ground meeting people every day, right? Um, can you share a little bit, Jameson, quickly on how a typical student and faculty kind of relationship or interaction is in this program?
Yeah. So we are unapologetically like, in-person, high intensity learning, right? We are not a boot camp. We are not online. We are not asynchronous. And the intention here is that, we engage with the students one-on-one, and we keep our classes relatively small in order to handle that, right? So, a typical cohort in Portland is, 20 to 25 students. A typical cohort in Salem is maybe 30 students. Um, uh, but anything larger than that, we start sectioning the classes so that we don't sacrifice the experience that the students get interacting with the instructors. The other thing is, the faculty are all, full kind of, uh, research active PhD faculty. These are the real deal. Like, these are not, adjuncts typically, unless we have a specialty course on occasion. But these are folks who know what they're doing, and who are in it all the time. And they're really good at what they do. Um, the the faculty typically will have office hours prior to class, um, and then open up additional virtual office hours at other times, and are often, well, I have a few faculty who will be on Discord with you at 3 a.m. if that's if that's the way that you like to operate. But they are very committed to their craft, and really take pride in the quality of their instruction. And so it's a bit of a premium experience compared to a lot of other programs that exist out there.
Thanks. Yeah. I'm an alumni of this program, and that's pretty in line with what my experience was. I had a few late nights typing away, trying to solve errors in my code with Professor Calvin on Discord. and Calvin's he's funny because he really likes to help you, and he likes to like almost give you the answer, but not quite. So you have to sit there and like, you're really close, and Calvin will know you're really close, and then you'll just have to like grind it out, it's a fun experience, right? But it's also like, it's 2 a.m. Can you please just tell me how to fix this? But that's where I learned how to debug stuff, because it was like Calvin helping me almost get to the finish line and then forcing me to cross it myself. So I don't know. But that's definitely the case with certain faculty members, and certain faculty members might not want to be up at 9 or at the middle of the night with you. But they all have this kind of personal attention and kind of care for their students and the work they're doing. And I think part of that's because of the small community we have here, with like only having 20-ish students in the cohorts, right? You get to know them really well, but also professors here are really into the content they're teaching, right? And that's their main focus, from what I could tell at Willamette, right, was the instruction they were giving students. So,
well, and we're getting nationally recognized too. As of last year, we were ranked 14th nationally for programs of this type, top program on the West Coast. And so it's nice to kind of see that recognition come through as well.
Awesome. Yeah, and if you guys don't have any questions, I think we've hit on all of what I think of as important stuff. But I'm sure there's other stuff that people find.
I actually did just think of a question.
Yeah.
I'm sitting here. Do you guys cover any sort of cloud infrastructure or architecture stuff in the engineering courses?
We do. I mean, it kind of depends on what you mean. So there are versions of kind of cloud application development that we don't cover, but we do cover cloud deployment of, for instance, like AWS containers for data engineering and that sort of stuff, right?
Mhm.
So, it's impossible to actually do enterprise data management without dealing in the cloud in some way. And so, especially as you kind of progress into advanced data engineering, you'll get exposure to some of that stuff.